Okay, so problem 5 says Owen put $1,830 into a savings account that earns 3.1% interest annually. And after 6 years, how much money will he have? So remember, look, notice one thing. It says not how much interest does he have, but how much money will he have. So to figure this one out, first we need to, in our notes, we should check our notes for this if we didn't know. But first we need to remember what the simple interest formula is. It says it's simple interest. And to calculate simple interest, the interest is equal to the principal times the rate times the amount of time. So I know that the principal amount, the original amount that he put in, so the interest is going to be equal to the 1830 here times the rate. The rate, it says, is our interest rate is 3.1%, and the time is 6 years. It says it's an annual rate, which means that it's happening once a year. So that's why I just write 6 in here. If it was like a monthly rate and it was 6 years, I would need to do like 6 times 12 or something. But it's an annual rate, so it's 6 times once a year. So then I would type all this into my calculator, and I should come up with $340.38. So that means that is the interest that Owen makes over 6 years just on this, if Owen doesn't do anything else to the money. But it doesn't ask how much interest it is. It asks how much money it is. So in order to figure out the total money is equal to the principal plus the interest, because it's not like he didn't go from 1830 to 300 to 340. He added 340 to his money. So the total money now after 6 years is the principal, which is 1830, plus the interest, which is 340.38, and the total amount for that is $2,170.38. So you got to add those together. I think I gave people half credit if they calculated the interest, but not full credit, because it does not ask you what the interest is. It asks you how much money will they have altogether, and it is important to distinguish the difference. Okay, final question. Final non-HP question. So this question is a comparison. It says, how much more money will you pay for a $475,000 house if you take out a 30-year loan at an annual interest rate of 4.75% than you would if you took out the same loan, so $475,000 30-year loan at 4.5%. Now I wanted to do this one so we could think about like how much money. A little 0.25% doesn't seem like very much, but it turns into a whole bunch of money. So it says these are both simple interest loans. So if you're calculating the simple interest here again, first of all, the first question is, how much more will you pay over the life of the loan? And the life of the loan means the complete 30-year loan. So once you've paid off all of your money after the 30-year loan. So if I wanted to calculate the simple interest here, I would multiply, again, it is the interest equals the principal times the rate times the time. And in this case, that would be the principal is the amount of the loan, $475,000 loan, times 4 times the rate, which is 4.75%, times the time, which is 30 years. It is an annual interest rate, so it's happening every 30 years. And when I put all of that money into my calculator, I come up with $676,875. That is just the interest on this loan. So that means I have to pay the $475,000 plus the interest. And then the other one was the interest is equal to the same thing. It is the same exact amount because it is the same loan. And the time is also the exact same, so 30 stays the same. The only thing that's different is this one is 4.5%. And if I calculate that, I put that all into my calculator. I type 475,000 times 4.5% times 30. Then I come up with 6. So this one is only 0.25% less, but over a 30-year loan with simple interest, we would end up paying $641,250. Now, some students may have added, to figure out the total amount that you would pay for the entire 30 years, you would also pay $475,000. But since we're paying it for both of these, since we're sort of adding $475,000 to both of these, you can do this, but you don't have to because it's the same. And what we're doing is we're comparing what's more. So when to figure out what's more, these are obviously the same size, so there isn't any more there. So I don't actually need to calculate this part. I can just actually erase that. I don't even need it. So that does not need to be calculated to figure out how much more you pay because it's the same. But if I subtract these, right, if I do 600, if I have $676,875, the difference between that and $641,250 is that I need to subtract $641,250, and then I come up with a difference of $35,625. That is the difference. So this is how much more you pay. So that 0.25% is going to cost you $35,625 more over the course of 30 years, which, if you do the math, that's that's a lot of money. And then the next part says, how much more will you pay per month? So a lot of students, so all you really need to figure this out is you just need to know how many months have you been paying this off for. You're going to be making monthly payments. How much are you paying? How long are you paying this off for? So I know that 30 years. First, I need to convert this into months. So 30 years times 12 months times 12 months per year. That equals 360 months. So I will be paying this off. There will be 360 months where I am paying off all of these loans. And what is the difference between those? Well, you could calculate these all, and you could say 676,875, and I could divide that by 360, and I could divide this by 360 and figure out what the difference is between them. But it shouldn't matter. It shouldn't have to do that because really I just want to know the difference. I should get the same answer even if I do this other way. So what I'm going to do is I'm going to take my difference and I'm going to divide the difference into 360 parts because that's how many months I'll be paying off this difference. So all I really have to do here is do 35,625 divided by 360. And it is equal to $98. This was dollars, by the way. $98 and 95.83 repeating cents. So I'm going to actually round that up to 96 cents. So every month for 360 months, you will pay $100 more that month just because of that 0.25%. So these little 0.25%, when they multiply can turn into a lot of money, even though they don't seem like very much. There were other ways to solve these problems. Obviously, there are lots of them, but I wanted to show you one for each. So for the highly proficient, it says that we need to figure out what the missing values are for these two similar figures. So the fact that they're similar figures means that all their angles should be the same and they should have proportional sides. And so because I know that the sides are proportional, like I can look for the corresponding sides. So I know that y goes with sort of this 13 length here, and I know that 67.5 corresponds with 9, and I know that 3z corresponds with 90, and I know that x corresponds with 4. So these are all sort of the corresponding sides. So if I want to go from one to the other, what I need to do is find a pair of sides that I know everything about. And you can see that I know some information about the yellow sides here. I know, but I'm missing some information. Missing some information about the top sides. The right sides I actually have everything about. So I know I have all of the information about both of these. So because they're proportional, I know that I'm just multiplying by a single number. So the question is, what number am I multiplying by to go from 9 to end up at 67.5? So in order to do that, what I'm going to do is I'm going to find the scale factor. And to find the scale factor here, 9 times what number equals 67.5? Well, I mean, to figure this out, I'm just dividing by 9, and that tells me that x should equal 67.5 divided by 9. And when I punch that into my calculator, 67.5 divided by 9 equals x equals 7.5. Oh, you know what? This is a little bit confusing too, because this is really my scale factor. My scale factor is equal to 7.5. So that means that when I have 9, I multiply times 7.5, and that will give me 67.5. So now I can use that information to figure out the rest of these. I know that 13 also has to get multiplied times 7.5. So y equals 13 times 7.5, which when I do that math, 13 times 7.5, I get 97.5. So now I know that y is equal to 97.5. And I have all of the information, or now I have enough information to solve x. I know that 4 times 7.5, x is equal to 4 times 7.5, which is 30. And if you got those ones right, you probably got, you're in like 7 range right now. If you try, let's see, I guess I'll stick with my colors here. To solve this last one though, it's a little bit more difficult, so it just requires an extra bit of thinking here. So 90 times, or 90, I know that if I'm going this way, I'm multiplying by 7.5. If I want to go the other way, I have to divide by 7.5. So 90 divided by 7.5 gives me 12. So 90 when I divide by 7.5 gives me 12. That does not mean that z is 12. That means that 3z is 12. So 3z is equal to 12. But to figure out what z is equal to, I need to use inverse operations. I'm going to divide 3 on both sides and figure out that z is equal to 4. So that is my final answer there. If you got that one right as well, you probably